Okay, so first we did it for just a number, so looking at a specific value of x. But the whole point of algebra is being able to look at a formula or a function that allows you to look at a relationship for any possible value of x. So now that you understand what's going on with one specific number, what we're going to do is really compose functions. So when you're composing functions, you're putting one function inside of another and simplifying. It's just fancy substitution. Usually your directions will say rewrite as a rule, and what that means is you're just creating a new function. So, for example, on number 3, if you let f of x equals 2x minus 1 and g of x equal 3x squared. First, we're going to look at doing f of g of x. What that means is that we are going to put g of x, because we're putting x into g, and taking that and sticking that inside of f. In some ways, this is easier than evaluating it for a number, because there's no first step. G of x is equal to 3x squared. So what we're really doing is evaluating this for f of, g of x. Well, g of x is 3x squared. So what we're going to be doing is everywhere there's an x in f of x, we're going to be putting 3x squared. And then you just simply simplify. You have a number outside of parentheses, distribute in, and what you get is that f of g of x is equal to, well, 2 times 3 is 6. You get 6x squared minus 1. And that is that. Going the other way, that one was a pretty simple one. Going the other way, it does get a little more complicated, but not too bad. If we're sticking f inside of g, that means everywhere there's an x in g of x, we're going to put all of f of x. And f of x we know is 2x minus 1. So what we're doing is evaluating g for 2x minus 1. So every single place there is an x in g, we're going to be putting 2x minus 1. Alright, now all we need to do is simplify this. You guys know we just got done going from vertex to standard form. This looks a lot like vertex form. Even if you don't remember that, anytime you have a binomial raised to a power, or raised to the second power, it's a trinomial in disguise. We need to box out that 2x minus 1 squared. You get 4x squared, negative 2x, negative 2x, positive 1. Don't forget to bring down this 3, and then bring all that out in front, so that's 4x squared minus 4x plus 1. Distribute the 3, and you're done. So g of f of x is equal to 12x squared minus 12x plus 3. Okay, 2 more examples. So here we just are using different functions, and they can give you absolutely anything. But what I've done on this one is I've included a quadratic that had both a quadratic term and a linear term, but most importantly, 2 different locations where there might be an x. Well, there is an x. So every single location there's an x, you have to substitute in the other function. So on part A here, we're doing f of g of x, and we're doing, again, f of g of x. So what's g of x? The g of x is 4x. in every single place there's an x here, we're going to be substituting in g of x. So that's 2 parentheses 4x squared minus 4x plus 5. So both of those x's, I'm going to have the 4x there. Okay, and now all I do is simplify. Now a very common mistake here is to mess this up. Now this 4 is raised to the second power. I'm not going to distribute this 2 yet. I'm just going to bring it down. 4 squared is 16. X squared is x squared minus 4x plus 5. And that means my final function for f of g of x is 2 times 16, which is 32. X squared minus 4x plus 5. Okay, one more to go, and I think this last one is the easiest one. If we're putting f of x inside of g, that means we're taking all of this and sticking it exactly where the x is there. So if I'm doing g of f of x, that means everywhere there's an x in g of x, I'm going to put all of f of x. And all of f of x is this big old quadratic here, 2x squared minus x plus 5. It looks messy, guys, but it is just fancy substitution. So where that x is after that 4, I'm going to substitute that mess, 2x squared minus x plus 5. And then my next step is to distribute 4 to every number there. So that becomes 8x squared minus 4x plus 20. And that is our final answer. There's no further way to simplify that. So g of f of x is equal to that. So what's going on is you're going to be given 2 functions, usually, sometimes more, sometimes less. And you're going to be taking one and sticking it into the other one, everywhere there's an x or whatever variable is there. And then you're going to just be simplifying. You're composing functions. It's like you're just throwing things inside of each other and seeing what happens. Okay, the end.